Let's solve a problem using the intermediate value theorem. We need to prove that there is at least one real solution to the equation f of x equals x cubed minus 4, x plus 1 equals 0 in the interval from 1 to 2. Let's solve this step by step. First, we note that f of x is a polynomial function. Since all polynomial functions are continuous, f of x is continuous everywhere. Next, let's evaluate f of x at x equals 1. When we substitute x equals 1, we get f of 1 equals 1 cubed minus 4 times 1 plus 1, which equals negative 2. Similarly, let's evaluate f of x at x equals 2. F of 2 equals 2 cubed minus 4 times 2 plus 1, which equals 8 minus 8 plus 1, which equals 1. Let's visualize this on a graph. Here's our function f of x equals x cubed minus 4x plus 1. We can see that at x equals 1, f of x is negative 2, and at x equals 2, f of x is positive 1. Now we can apply the intermediate value theorem. Since f of x is continuous on the interval from 1 to 2, and f of 1 is negative 2, while f of 2 is positive 1, there must be some value c between 1 and 2 where f of c equals 0. Therefore, we have proved that there is at least one real solution to the equation f of x equals 0 in the interval from 1 to 2. This solution exists because the function is continuous and changes from negative to positive over the interval.